Get started. It's my pleasure to talk about and be able to moderate a session on two of the emerging projects that are coming out of Global Alliance. One of them, both John Mattison, who's the Chief Medical Information Officer from Kaiser Permanente, is going to kick us off with that. So, John.
Thanks, Heidi. So quickly, what we're going to do is Gil's going to first cover some of his amazing work at cataloging various efforts to manage ontologies around the world, and then look at some of the implications for how to increase collaboration through cross-fertilization of both governance and publication. I am then going to look at the opportunity to proactively manage the evolution of how data models, ontologies, APIs may solve the dilemma of too much complexity already in existence and the need to simplify and create an evolutionary stream for how we manage the future of data models. So Gil, please go ahead and speak to your work.
Yeah, thank you very much, Sean. So let's get the clicker here working. All right. So, hi, my name is Gil Alterovitz, and I just wanted to talk to you a little bit about the eHealth task team's new work product, which is the catalog of activities. So, first of all, just a quick background on the catalog of activities. It's really an online resource, one that allows us to make a catalog, a listing of all the different activities in this area of clinical and genomic sharing and interoperability in terms of the information that we now have out there, in terms of initiatives, tools, repositories, and so forth. And really the scope is to be able to reach and to be able to allow a searchable tool that is, for our audience, which is involves both genetic researchers who are interested in clinical data and clinical researchers as well as physicians who may be interested in knowing what standards organizations and what kind of initiatives there are that they could participate in terms of sharing their data and also linking to genomic information. So we created a map. We created first actually a list of all these different activities by reaching out to different members in the clinical work group, by reaching out to thought leaders throughout the world, put together a list of all the different initiatives related to, as I mentioned, clinical and genomic interoperability, repositories, tools, data sharing, and so forth, and then mapped it onto the globe here. And as you can see, it actually follows pretty much along the lines of where we have representation for the Global Alliance. The question there is it based on selection bias, potentially because we reached out to members of the Alliance. But as you'll see, we are now expanding the opportunities to add to this catalog by seeking feedback and actually actively promoting its use and search in developing countries as well. If you can look and get additional information about these maps, and it's actually available, the whole catalog, as of version 1, which is a version that has information that we've gathered together and is available online at this website. We're currently working on version 2, and a number of the items that I'll show you next are actually analyzing the database from version 2. So right now we're in the gathering feedback phase. So if you go to that webpage, there's an opportunity to give feedback. And then we're also doing analysis of this new version of data that integrates both information that we've gathered as well as other initiatives that have essentially donated the data that they've gathered, so that there's one common unified initiative under the Global Alliance. So I'd like to share with you actually one of these items, which looks at how can we potentially take a database that we've created and actually learn something new about how people collaborate, how people work together, and is there something that we can learn about that from analyzing such a database. And so here what you have are these nodes of these organizations, and there's a link between the organizations if there have been co-authored papers between leaders within that organization. What we did is we compared that network with other networks, such as who is leading that organization, and is there shared governance among the organizations. And here you can see in the lower left-hand corner kind of a relatively simple analysis that we first did as a first pass to look at co-authorship, for example, without co-leadership. And you can see that there's much less interaction in that case. When you do all the different comparisons and eventually calculate the p-value, you get a more thorough analysis, and we find essentially that there's definitely a significant association, a link between having co-governance, co-leadership, and co-publication, which we're taking as a proxy for collaboration. So essentially, in short, what we find is that there's co-authorship links are significantly more likely with co-leadership among organizations. And that actually suggests a number of interesting ways that we can potentially foster a lot of the missions of the Global Alliance. So for example, I know there have been a number of discussions, for example, about involving the developing world. You know, as you saw on the map, there weren't as many developing world countries. Through a number of different initiatives. For example, I remember infectious diseases was mentioned and a few others. When we start thinking about these initiatives in terms of how to do collaborations, this kind of way may help to motivate people to work together. And so increasing leadership among shared initiatives is one way of potentially increasing collaboration. And the same thing could be true in the Global Alliance too, within its work groups, if there is shared leadership among the work groups. And so really the problem is that leaders have limited time. So every leader can't be in every other committee, right? And so a couple of potential models that we've been exploring and looking at based on this right now is a daisy chain model of co-leadership, where you have one or two co-leaders that allow for this chain, as you see here in this diagram, to have a co-leadership and a message passing between the different groups. And then another model, which I, as a member also of HL7, have taken on with HL7, is kind of this ambassador and liaison model, where HL7 selected basically for the clinical genomics work group that I'll be an ambassador to Global Alliance, and then whenever Global Alliance has some messages to relay, then I can relay those to the HL7 clinical genomics work group. So those are just a couple of models that I wanted to go over. And then, so as we've kind of discussed, really, we've created this network which has taken feedback from a number of you, a database of different initiatives, of different repositories for sharing clinical genomic information, using that information. And we encourage feedback to add in more initiatives. And as we look forward into the future, there are a number of different initiatives that we're planning on to make this even bigger. So we'd like to enhance the database that's currently on there in terms of more searchable functions. We'd like to publicize it to the broader community, recruit developing countries potentially on a number of initiatives. I've proposed a couple of those, and there are a number of others on the table. There's a focus on efforts to supporting perhaps select initiatives so that we can foster collaboration from some of those hubs and spread the message around to some of the other initiatives. And I outlined a few here. And then looking kind of into the future, we may be able to learn from this to foster collaborations from the beginning between different organizations, and then perhaps to write a review paper that integrates the feedback that we got, lists all the organizations and how we're learning about how to collaborate. And then finally, it'd be useful to add in links to common documents and resources that can help in sharing. And so that way we kind of provide an added layer on top of sharing all the different resources. We kind of add a curation layer that provides common documents that might be useful to everyone. So with that, I'd like to thank a number of people listed here and to welcome John back. Yeah, thank you.
Thanks, Gil. Just two things I want to highlight about Gil's brilliant work. The first is that their trust is very, very difficult to build, very easy to lose. And what he's illustrated is a model of accelerating trust between initiatives and facilitating collaboration by cross-fertilization of governance. So I would actually encourage every one of you to think about what is another institution that resembles your own in terms of its mission, its use cases, its semantic representations, and begin a dialogue about having cross-fertilization of governance, because I think that could be a very useful social construct for enhancing trust and collaboration. The second point is when you look at Gil's inventory of work around the world, we suffer from the same thing that most other domains suffer from, and that is the biggest problem of standards is that there are too many standards. Not that there are too few or there isn't a perfect one, but there are too many that represents a real problem. So what I'm going to talk about now is what are the implications for big data and what I call the plecosystem, which is a multi-platform ecosystem. What are the implications for semantic representations, data models, ontologies, APIs, and how do we manage that for global omics collaborations? So a couple of quick quotes, mostly from today, but they sort of frame what I'm about to address. So the first is from Mike Snyder, Chair of Genetics at Stanford, who in 2011 said there's no such thing as a common disease in the world of genomics. And we're seeing that in every disease state, the subtyping and micro-cohorting of diseases. Heidi this morning said an important future direction is to support hypothesis-free matching in the absence of an identified candidate gene. And I'll come back to that. John Burns said, I want to curate a response to complete profile in 10 seconds on my smartphone. And that is a brilliant statement of where we should be headed. Ewan said, sample size is king, so federation is essential, and the Alliance has a model that works between research and healthcare, and I'll come back to that with a construct for the plecosystem. David Hauser said, no one institute has enough on its own to make progress, collaborate on interface, compete on implementation. Graph-based human genome representation is a game changer. We need to expose the evidence supporting genotype-phenotype relationships. These are all sort of au courant memes of the Global Alliance that I think are going to have profound persistence as guiding principles. David Altshuler said the Global Alliance is moving incredibly fast, but the world's moving even faster. We need to ensure that in the spirit of trying to solve all problems, we don't solve any problems. And most importantly, we need to have a laser-like focus on how to make a difference. And then finally, Alex Soleil, who was the David Altshuler of the Sky Project, where they integrated all of the astrophysical information in the universe, literally, of the universe into a single sky map. His comment to me on Saturday while flying out here was the technical problems are easy compared to the sociologic problems in NIH. That's not the National Institutes of Health, but not invented here. So I like to think of what big data is doing as an inverted Big Bang. So in the original Big Bang 14 billion years ago, what happened was all matter and energy was concentrated in a single point in space and time. And after the Big Bang, there was an accelerating dispersion of matter and energy over time and space. What big data does is a perfect inverse analog, and that is that there's an accelerating convergence of data and knowledge into a point in time and space, which has lots of implications. The big data world is widely misunderstood in how it operates. So basically, the big data world with the fundamental distinction is that it allows for more of a relationship-free view of data, so you can actually let the data speak and look for relationships that were heretofore unappreciated, and begin to look for hypothesis generated by those data. So the hypothesis generating role of big data versus the hypothesis testing and confirmation in the conventional database world. So visualization tools become critical, and their implications for coexistence of big data and conventional database worlds and the persistence of both of them in the long term. So this is my messy slide. This is the term I invented called plecosystem, which is a multi-platform ecosystem with 4 axes. I'm just going to speak to the data platforms here, the panorome, the genome, transcriptome, proteome, lipidome, digital phenome, immunome, exposome, socialome, yada, yada, there's an epidemic of omics. But they all have their own intrinsic semantic representations. We have API platforms, experience platforms, and then the 4 principles I want to speak to. There's exponential growth across all of these 4 dimensions and each of the subcomponents. There's synergy, so the value rises exponentially with a number of nodes accessible and the number of omics linked across the ecosystem. So I hybridized Metcalfe's law, which the geeks are all familiar with the exponential growth of value in each additional node in a network, to describe this phenomenon. Data liquidity is critical, so federation of data, and then person centricity. It doesn't help us at all to have a huge proteome database over here and a huge lipidome database over here and a huge exposome database over here unless you can link it by individual. The relationships we're after are all person-centric. So how is big data different? I spoke to that earlier. Is ontology a one-word oxymoron? And ontology implies that there is a single right way of organizing all information in a reference model. Why does that matter, and what are the implications for collaboration? So potential implications of what I see as an unnecessary proliferation of different semantic representations. So all of the different ways of looking at data have tremendous overlaps, and some of them are functional, representing different families of use cases. So if you look at a family of use cases and a family of queries associated with those use cases, there are some sets of perspectives based upon use cases that condition a particular semantic representation and the associated data model, database schema, ontology, APIs, and so forth. But the set that we have is way too big. And so how do we think about constraining that set to a smaller number of semantic representations that are fit for purpose for a particular inquiry, a type of inquiry and set of questions, and eliminate what is purely parochial variation because people are still doing this in silos as opposed to bringing about convergence? How do we create an evidence-based approach to converging on a smaller set of ontologies and data representations? So the first thing is to use federated data enclaves with credentialing of researchers and federated researcher identity management and federated unique record matching. So one of the problems that lies in the very near future is duplication of records. And so we don't have to identify who they are, but to identify that they're unique and common in different data sets is important. We need to consider subtotal federations within the federation as are warranted by common use cases, and this is where that shared governance becomes really valuable and realistic, and as required by local regulatory constraints around privacy and so forth. We may want to focus initially on a lighter API representation so that they can actually work on target data representations without getting too granular in their approach, and then create evolutionary pathways for expanding those APIs over time. Keep it simple initially and then expand. Mechanisms for micro-consent, which Dixie Baker has so brilliantly elaborated in the work group, and perhaps even a microcredit for accounting mechanisms to know where the flow of data, is there data hoarding going on? Is somebody just sucking up from data from other sources and not really contributing? What is the role of a data concierge? So if you've ever tried to operate on someone else's data model that you're not familiar with, you know that it's very treacherous. You can create misleading results, and you can have misleading interpretations of the data if you don't really understand the depth and breadth of the metadata associated with those data. So a data concierge is someone who actually really understands the metadata and where the matrix is sparse and where it's dense, and how to really become a guide for someone trying to navigate through those data sets. As I mentioned earlier, creation of a small number of end-state use case families which are supported by fit-for-purpose data representation, semantics, ontologies, database schemas, however you characterize it, and which support families of queries. And then develop evolutionary principles and pathways to centralized approaches when appropriate. And as Gil pointed out in his evaluation, the cross-fertilization of governance to enhance collaboration and trust. Last slide. I believe that ontology is a one-word oxymoron. in that there isn't a single ontology that can capture an optimization of the way you think about the relationships between concepts in a particular space that subsumes all knowledge and all data. I believe that an ontology, the best ontology is in the eye of the beholder, and that represents the set of questions, queries, and use cases that you're pursuing. And so we need to facilitate convergence on a smaller set of ontologies and semantic representations over time. And there are some formalisms using matrix analysis that Ravi Panya has introduced me to very recently here, that we can begin to apply and have an evidence basis for how we constrain the number of terminologies. Now, that's not to say that vendor adoption and market penetration doesn't dwarf this evidence-based approach, but we can use the evidence-based approach to guide vendor adoption and market penetration. And then finally, as we use common data sets as a substrate for both big data analytics and conventional analytics, we can expose the Darwinian advantages that do accrue to use case specific data models that facilitate the data migration back and forth between the environment that is optimized for hypothesis generation vis-a-vis the environment that's optimized for hypothesis validation. And so I believe that both of those data environments have merit, will persist for at least the foreseeable future, and the extent to which that we rely on moving data and queries back and forth between those environments and back and forth between institutions with different representations, every single hop and transformation of that pathway is associated with semantic degradation. So as we federate our work, as we federate the data, as we federate our queries, arriving at a smaller constrained set of semantic representations will reduce the semantic degradation intrinsic to those multiple hop transformations. So that's basically it. These are the people who have contributed to this work. It's ongoing. And with that, Gil and I would be happy to take questions. Thank you.
If anybody has any questions, come on up. Maybe I'll start out. A lot of us, and I think Ewan said this very well, have thought about the fact that we need to capture data from the clinical care systems, the electronic health records. How do you see the easiest way to do that? And I can, think about two different models to start us off, which is one, working with the EHR vendors and trying to figure out a way to capture that. The other is to go to the patients and have a sort of blue button approach of, I want to share my data, get it out of the system, and here it is. How do you think about how to start to really engage the clinical care systems and how we can capture that data?
So I'm a big fan of both models of blue button consumer-centric, whether it's blue button or not. I'm leading an open notes initiative in Kaiser Permanente right now. Tom DeBonco of Harvard pioneered this work, where when I sign a patient's progress note, it goes to the chart, it goes to their web portal simultaneously so they have access to their whole record, and with a single blue button push, you can generate a digital copy of the chart that they can contribute to whomever they want. I think that's critical. I think it's going to drive a lot of progress in the whole issue of trust and ownership of records. As far as bulk transfer of data from health records into analytic environments, we do a lot of that. And the most important thing I would submit is that while I spent a lot of my career, I'm the founder of the XML standard for health record exchange called the Clinical Document Architecture and the Continuity Care Document. I spent a lot of my career trying to specify standards for how to represent it. I also have a team of about 20 folks who do natural language processing, and when I want to ask a specific question, I can frequently get a more reliable, richer answer with pure NLP than I can with mining discrete data. And not that they're exclusive of each other, but if I had to choose between the two, natural language processing is profoundly useful in the clinical manifestation world of electronic health records. And so the specific semantic representations and the level of granularity of those representations is helpful. But when you force a doctor to fill out a checkbox on a pick list, they will always pick something. And if they're in a hurry, woe is ye who interprets that as a valid discrete data element. And we've often found more accurate descriptions of what actually happened through natural language processing than through discrete data. So be very careful thinking that if we just define all the discrete elements we want for every rare disease, we'll get every doctor to do that accurately. it's as often as not misleading as it is helpful. So natural language processing plays a role. So to get back to your question of how do we imagine this, I think what David Hauser said earlier about we need to expose the evidence basis that links the phenome to the genome is probably going to be a more difficult problem than exposing the phenome because of the emergence of really powerful natural language processing tools on top of the semantics that exist. Finally, caveat emptor, when you ask a doctor to put discrete data in the chart, it's frequently very inaccurate.
Thanks. David.
So, John, you've lived in both sides of this. You worked in a big organization that actually implemented enterprise software, and you obviously have a vision and all that. How do you imagine vendor uptake and market penetration? In other words, like everything we're doing could be nice, but if it doesn't actually get implemented in the healthcare system, in some ways it's not going to have any value. So what, in your experience at Kaiser or elsewhere, actually drives vendor uptake? And what do we need to do as just this community to be relevant to what will actually happen in the world at large? So
let me first confess the reason I'm here is because David and I were on a Jason's panel together, and he asked me if I had an interest in doing this after having done similar thing in the phenotypic world. And to answer your question, the ability to get to vendors is through their clients. They respond very much to who pays the bill. And so when David Blumenthal, the third director of the Office of National Coordinator of Health IT in the US, pulled me aside at a meeting 3 years ago and said, we're doing a vendor evaluation for Harvard Partners to get an electronic health record. Do you have any advice and counsel about how to approach the vendors? And I said, there's only one thing that matters. Make them commit in writing to what extent they're going to publish open APIs to be able to get at the data. I personally have had many lengthy and sometimes very heated conversations with various vendors about their willingness to publish open APIs so you can access the data, so you don't have to rely on these Byzantine data representations that characterize the landscape of electronic health records of today. And we're getting progress in the U.S. The vendors are largely international. Epic has a big international presence. And so to the extent that we can leverage them through people demanding open APIs before they put the money on the table to purchase the application, I think we're getting some traction. And the CEOs of Cerner and Epic are both moving in that direction. I'd like to see it a lot faster.
Great. Thank you both for your comments, and I think we're going to move on to Mark's talk. So.